So we are here to talk about Streamline web application deployment on AWS Lambda. So web applications are a really popular way to build your applications, right? We build a front end with framework like Next.js or Remix or stuff. And we also build REST APIs using Spring Boot or Flask or Fast API, and or maybe using Laravel. And these frameworks are great. You give you great functionalities, abstractions, and it has good tool support, easy to debug, to develop locally. But how to deploy those applications into AWS Lambda in an easy way without modify a lot of code? That's the topic that I'm going to show you today. So why want to do this? The AWS Lambda has some serverless operation benefits to you, right? Because Lambda scales up really fast, and you don't need to manage the capacity and do not need to patch the operation systems, right? But Lambda has a pretty particular programming model. It's event-driven. You write a handler, and when Lambda receives the request, it gives you a JSON payload, which is not HTTP request, right? So somehow, if you wanted to deploy web applications into Lambda, you need to do a translation between those. So if we can easily deploy, then we can use familiar frameworks to leverage your skills and learning, and also enjoy the serverless benefits. And also, we are able to move our applications between EC2, Kubernetes, and Lambda easily. That's a benefit that we are trying to gain from this session. So there's a tool that we created, an open source. It's called AWS Lambda Web Adapter. It is a Rust runtime. It's a Lambda extension that is written in Rust. And you add this extension to your Lambda function. Then you will be able to run any web frameworks written in any language, run that on Lambda. There's no need to add any extra dependencies or libraries in your web application. Web Adapter will take care of the translation between Lambda's interface and your web application. So at a high level, this is how Web Adapter works. So on the left side is Lambda's service endpoint. On the right is one of the Lambda's execution environment. Inside the execution environment, Lambda provides runtime APIs. Web Adapter is an extension. It sits between the Lambda's runtime API and your web application. And once Lambda service receives HTTP requests, it will send that payload through runtime API to Web Adapter. Web Adapter will translate that JSON payload into a HTTP request, and then will send that request to your web application at your port that listening on. And your web application can handle the run whatever you want to do, and return a HTTP response. And Web Adapter will translate that HTTP response to a JSON payload that Lambda's runtime API understands. So this is a high level of how things works. Before we go into more details, I wanted to show you Lambda's execution's lifecycle. This is a high level. Each Lambda's execution environment has 3 phases. The first phase is initialization, and followed by several invocations, and finally shutdown phase. And something that's very special is initialization phase. Initialization phase, there's 3 parts. At first, Lambda will start all the extensions that attach to your function. It automatically starts them. Then once the extension finishes registration, it will start the runtime process. Then when runtime finishes, it will load your functions init stuff. Once this init phase is done, this environment or this micro VM are ready to process multiple requests. Once this environment was idle for some time, or it's reached maximum duration, it will be recycled, it will be shut down phase. But we need to look at initialization phase, because this is the phase that is special, that web adapter to make your web application run in Lambda. So runtime API is a process that is provided by Lambda. Adapter is a separate binary. It's also a separate process. Web application is your thing. When it starts, runtime API will first start all the runtime, all the extensions. Web adapter is the extension. So it will be started before your web application starts. And web adapter will, once it's started up, it will tell the runtime API that I'm ready. Then runtime API will find a way to start your web application. But there is one question is, how do we know that your web application is already started up and ready to receive requests, right? Otherwise, if we finish this initial process phase without ensure your web application is running, then later on the requests coming in, your web application is not ready, then there will be errors to the client. So at this phase, web adapter will send, by default, it will send HTTP GET request to 8080 at a /root path. And if your web application is not up and running, this request will fail. Web adapter will continue to send the request readiness check to your application until your application is up and send a response to like HTTP 200 or even 400 or whatever. Once your application sends HTTP response to web adapter, it knows that your app is up and ready on that pod you are specified. And once that's done, web adapter will tell Lambda that we are ready for work. Initialization is finished. We can do the invocation now. So let's go to look at how can we package a web application and easily add the web adapter. Then you can deploy that into Lambda. This is an example Docker file. This is packaging of Express.js, Node.js application. The only line is this one. This one is actually copy Lambda Web Adapter binary from a Docker image that we provide into a very specific directory inside your Docker file, inside your Docker image, which is under OPT extensions. This directory is kind of magic or special for Lambda functions. When Lambda starts up your execution environment, it will look under that directory for any executables. They will regard those executables as Lambda extensions. Then it will automatically start them. That's how Lambda Web Adapter gets started by the Lambda service. Rest of it is just normal, simple Express.js packaging. And you use a command or normal way to start up your Express.js applications. Okay? The good thing is, if you build a Docker image using this with that one line of code to add a web adapter, this Docker image, you can deploy it on Lambda, and also you can run it without modification, run EC2 instance or Kubernetes, or even on your desktop computers. So you got the ability to port your web applications on a server or container or serverless compute environment. Lambda also has another way to package your application, which is using zip. Web adapter, you can also use web adapter in the zip package format. This is a SAN template for example. We provide web adapter as a layer, so you need to add a layer to your function, and you also need to do a little bit extra step to configure it. You need to configure an environment variable called AWS Lambda execute wrapper. This will point to a file that provided by that layer, then this wrapper will start up one thing that's run.sh. This is the file you are going to provide. Inside this script, you will find whatever ways to start your web application process. Okay. So this is how you package Lambda Web Adapter and your web application using zip and deploy to Lambda function. So that's very simple, quick introduction on Web Adapter. So I'll give you a demo how to deploy a real Next.js web applications onto Lambda. We package that into a Docker image and deploy it to Lambda function, expose it with a Lambda function URL. Lambda function URL is the HTTP endpoint that provided by Lambda service. You can, without charge, it's free to use. You can just directly hit your function. But it's web application, right? We put CloudFront CDN in front of it, and also we can put the custom domain name onto it. One thing about function URL is it is free, but it has limitations. You cannot configure a custom domain name to the function URL. So one way to do that, to give a function custom domain name to function URL, is to put a CloudFront distribution in front of it. Then you can add custom domain name to the CloudFront. So let me switch. Okay. Can you say okay, or do we need to enlarge it? Okay. Okay. Good. So this is a Next.js application. Yeah, it's a Next.js 14.1. So use app router. There's a layout page and some API stuff. Pretty simple one. And here's the Docker file. This Docker file used two-stage build to build the Next.js application. The first stage is just to install all the dependencies for your Next.js application. Then second stage is actually create a runner and copy Web Adapter into it. And we need to do a little bit extra stuff to copy Next.js files. We build the Next.js application in a standalone mode so that it provides a Node.js server that we can just copy over and to run it. There's one very specific thing that we do here is there's one restriction for Lambda's runtime environment. Its file system is read-only except the temp. But sometimes Next.js has some need to create cache during runtime, and then that directory is under .next cache directory. If we do not change anything, that directory will be read-only. At runtime, Next.js cannot write to that directory. So when we create this Docker file, we create a symbolic link to a temp directory to solve this problem. And we also have a run.sh file to actually start the Node.js server and create this directory as well. So now, to deploy this, I have some template file. Inside this SAN template, there is a serverless function, which is Lambda function, and it uses Docker image to build that. And it's on x62 CPU structure. It has function URL attached without authentication, which is open. And there's one thing called the invoke mode response streaming. This one is something Lambda supports. So Lambda has two response modes. One is batched, one is response streaming. In this example, we're going to show you we can use Next.js suspense and the response streaming, and together with function URL to create a faster time to the first byte and stuff. And to specifically support this response streaming mode, on the web adapter, you also need to specify this. That's how it works. Then this is just some output to tell you what is the function URL that you can expect. But before I deploy it to Lambda, I can actually run it locally to show you it's actually working Next.js replication. So I run npm run div. This starts a local Next.js div server on localhost 3000. So this is a Next.js example for a streaming response. When you load this, you can see the product information comes quickly. Then after some seconds, the recommended products come up. And after another several seconds, the customer review comes up. This is we specifically delay those things. We are simulating that you are calling backend service APIs to get those informations. Those operations takes time. If you do not do the streaming stuff, this page will show after everything is available. That's gonna take like 10 seconds something. So that's not a great user experience, right? But you enable streaming, then we can get everything very fast. So this is locally running. We can run a command, use SAM build and SAM deploy to build this function, create a Docker image, and push to ECR repository, and it automatically create a Lambda function for you. And it also will create a function URL configured for you. Because I already deployed it, so this is already in the Lambda service. So if we go back, if I go to Lambda console, oh, sorry. Quickly. Okay, so here we go. We can see there's function there, Next.js streaming, and we have a Docker image, we have a configuration, we have this function URL. We can click this function URL, try to access this application. You can see it runs exactly like what we're seeing running locally. So we don't modify this application any line of code. We just add a web adapter into the Docker image and create a function in Lambda, and we get this. And we can put a CloudFront distribution in front of it to give a custom domain name. So this is something I already set up. So Next.js demo, then it will invoke the same Lambda function, but you got the custom domain name that you need. Okay, so this is how it works. Let me switch him back again. So this is the architecture that you just saw in the demo. We have a Next.js application packaged in Docker with a web adapter attached and with a streaming response enabled and through the function URL. And we put CloudFront in front of it, have the custom domain name to access it. So this is a very simple way to move a web application into Lambda. Of course, this is a simple architecture. Next.js has static files. You probably should put them into S3 and have a CloudFront put to route those requests to S3. There's you can do more advanced things because this is just single region deployment. We can actually deploy these Lambda functions in multiple regions and use this CloudFront to route your users to the closest region or lowest latency regions to reduce your user perceived latency, so that over the globe, your user will get like 100 or 200 milliseconds latency instead of 2 or 3 seconds. Right? That's something you can do with all this. Okay, one more slide is I'll give you some resource. The first one is Lambda Web Adapter's GitHub repo. There is a lot of examples you can see go through. And on the right is a blog post to talk about exactly the same architecture in AWS Compute blog. So cool. I think that's all. Thank you. Thank you for coming. Yeah, we can go over there and take your questions.